Hey there, stats class. It's Miss Perry, and I'm super excited to try out this screencast to help you get ready for your test on Monday. So, in class on Thursday, I gave you these questions on sampling distributions. I'm going to try to walk you through them all. Question 1. A survey asks a random sample of 500 adults in Ohio if they support an increase in the state's sales tax from 5% to 6% with the additional revenue going to education. Let P hat denote the proportion in the sample who says they support the increase. Suppose that 53% of all adults in Ohio support the increase. Part A. What is the sampling distribution for P hat? Whenever you're asked about a sampling distribution, your answer is going to be two things, the mean and the standard deviation. Since we're talking about P hat, we're looking for mu sub P hat, the mean of a sample proportion. We know if we take a good enough sample, then our sample proportion will be equal to the true proportion. In this case, we're told it's 53%. So mu sub P hat is 0.53. The second half of the sampling distribution is the standard deviation, sigma sub P hat. We have a formula for that one. It's the square root of P, the true proportion, times Q, 1 minus P, all over N, the sample size. So square root of 0.53 times 0.47 divided by, in this case, we asked 500 adults. Calculating that out, 0.0223 is our standard deviation. That's all of Part A. Let's move on to Part B. Part B says, what is the probability that less than half of the sample will say they support the increase? This question is asking you to calculate the probability that your sample proportion will be less than 0.5. First thing I need, now that I have my sampling distribution from Part A, is I can go ahead and get my z-score. Z-score formula, remember, is x minus x bar over s. So in our case, we're going to say z equals 0.5 minus 0.53, the mean we had from above, divided by the standard deviation we calculated in Part A. That works out to negative 1.35 as my z-score. I always like to draw myself a little picture of a bell curve so that I know exactly what values I'm looking for. So my z-score was negative 1.35. It's right about here. And I'm looking for the area less than that. That's this area here. Now you know you have two choices to find that area. You can go to your table, or you can do this on your calculator. Calculator code for this case would be normal CDF, negative 100 being my safe minimum. My maximum in this case is my z-score, the mean of the standard normal, and the standard deviation for the standard normal. This results in 0.08851, which is the same answer, or close to, that you should have come up with from the table. Part C, interpret your answer to Part B in context. Here's my interpretation for you. Less than 9% of all random samples of 500 Ohio adults will result in less than a 50% approval for increasing the sales tax from 5% to 6%. Hope that sounds good. Let's go on to Part 2. So question 2 is about scores on an IQ test. All right, so scores on a standard IQ test for the 20 to 34-year-old age group are approximately normally distributed with a mean of 110 and a standard deviation of 25 points. Part A, what is the probability that a simple random sample of 200 adults between the ages of 20 and 34 will have an average IQ within 2 points of the mean? So, in order to answer this question, I usually like to start out by getting my mean and my standard deviation. Now I'm talking about a simple random sample of 200 adults. So I'm not going to use the population mean and standard deviation. I'm going to find my mu sub x bar and my sigma sub x bar. Mu sub x bar, I know if I take a good enough sample, then I know my sample average will be equal to my true average. In this case, 110. Sigma sub x bar is a different formula than sigma sub p hat. This guy is population standard deviation divided by the square root of the sample size. Population standard deviation is 25 divided by the square root of how many adults are we talking about here? 200. Calculating that out, I get 1.7678 as my standard deviation. So my mean for my sample distribution is 110, and my standard deviation is 1.7678 points. Now, let's talk about the probability we're asked to find. It says we're looking for an average IQ within 2 points of the mean. So this means 2 points below or 2 points above. So the probability that, let's see, 110 minus 2, 108, is less than my average, is less than 2 points over that, or 112. So that's the probability I'm asked to find here. Whenever we do intervals, we know we need 2 z-scores. So I'm going to need a z-score for my minimum, using the same z-score formula from before, 108 minus my mean, divided by my sample standard deviation, gets me a z-score of negative 1.13. Well, I also need a z-score for my maximum, the upper end of my interval. 112 minus 110 divided by 1.7678. Now, I should expect here to get the positive value, 1.13, because of the symmetry of the normal distribution. Again, I'm just going to sketch myself a little bell curve. Here's mu. There's 1 sigma, 2 sigmas, negative 1 sigmas, negative 2 sigmas. My z-scores are about here to here. I'm looking for the area between these two things. Now, if you're going to do this area in the tables, you're going to have to look up both of those values and subtract. If you're going to do this on the calculator, you're going to save yourself a lot of work. You're going to do normal CDF, and our minimum and maximum values are going to be our 2 z-scores. So negative 1.13, comma 1.13, comma the mean of the standard normal, and the standard deviation of the standard normal. The calculator is going to go ahead and spit out for us 0.7415. And if you use the tables correctly, multiplied in the right order, subtracted your z-scores in the right order, you should get the same answer that we did in the calculator. All right, let's talk about the interpretation. Oh, there is no interpretation for this one. Let's interpret it anyway. Just for more practice, our probability here of 0.7415 says about 74% of all samples of 200 adults between the ages of 20 and 34 will have an average IQ between 108 and 112 points on this test. So, extra practice interpreting. Now let's go to that part B. How many adults would need to be sampled to have a standard deviation of only 1 point? So this is one of those questions where I tell you the standard deviation I want, and I want you to work backwards and solve for my sample size. So we're not really concerned anymore about a sample size of 200. We're going to find a new sample size. So remember, we're working with x bars here. So my sigma sub x bar formula was population standard deviation over the square root of the sample size. I'm going to substitute in my 1, the standard deviation I want, for the standard deviation of my sample. So 1 equals my population standard deviation from the question, remember, was 25. And I'm going to divide that by the square root of n. So everything after here is algebra. I'm going to start by multiplying both sides by the square root of n. That cancels this guy out over here. The square root of n times 1 is the square root of n equals 25. Now, don't get excited and shout out 5. Remember, we're working in an opposite direction here, so I need to square both sides. So n equals 25 squared. That's 625. So I would need a sample size of 625 adults in order to cut my standard deviation all the way down to only 1 point. There's one more question on this page. Let's take a look at the chipmunks. The chipmunk population in a certain area is known to have a mean weight of 84 grams and a standard deviation of 18 grams. Part A. Find the probability that a randomly selected chipmunk weighs at least 90 grams. All right, so this doesn't say anything about a sample because we're only talking about one single chipmunk. So this is a pretty straightforward question on normal distributions and z-scores. This guy's asking you for the probability that my one single chipmunk weighs at least 90 grams. So I'm going to find a z-score. Z-score formula is x minus x bar over standard deviation. And because I'm only talking about an individual chipmunk here, I'm going to use my population information from my question. So 90 minus the population mean 84 divided by the standard deviation for the population, 18. That all works out to 0.33. I'm going to go ahead, sketch out my normal curve with my mu in the middle, my standard deviations floating around. My z-score was 0.33, so it's right about here, and I'm looking for at least. So that's greater than or equal to. That's this area on this side. So if I go to the z-tables from here, this is going to be a 1 minus the area I read out of the table. If I do this on the calculator, I'm going to say normal, CDF. My minimum this time is my actual z-score, this value here, 0.33, all the way up to my maximum. So I want to keep calculating area way, 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 way out in the positive direction. So I'm going to safely go out to 100. The mean of the standard normal is 0. The standard deviation of standard normal is 1. That's my calculator command. I get 0.3707, which should be pretty close to what the z-table told you if you calculated everything correctly that way. So let's interpret it this one. 37% of randomly selected chipmunks will weigh at least 90 grams. That was the easiest sentence I wrote all week. Ready for part C? A wildlife biologist weighs 9 chipmunks that have been caught in live traps before releasing them. Right away, I know I'm talking about more than one chipmunk. What is the probability that the chipmunks weigh an average of at least 90 grams? So I've got 9 chipmunks. What's the probability that my sample of chipmunks has an average weight of 90? So this guy is actually talking about the probability that x bar is at least 90 grams. Not x anymore, x bar. We're going to have a sample of 9 chipmunks. So I'm not going to be able to use my population information this time from the question, but I can use it to get my mean and standard deviation for my sample. Mu sub x bar, remember, is equal to mu if we take good enough sample. We're assuming we did here. So our mean was 84 grams. Standard deviation, sigma sub x bar, remember, was that formula, population standard deviation divided by the square root of the sample size. Population standard deviation was 18, divided by the square root of our sample size, 9 chipmunks. That comes out to 6. Is our new standard deviation.